Okay, so that's all the concepts. Here's what the homework is going to be. Of course, that's posted in all the usual places. I just want to go through a couple of these problems to sort of show you what I'm expecting you to write. So if we look at page 441, these are all in section 8.1. Page 441, number 12. Here's your directions. They want you to state the common difference, the eighth term, a recursive rule, and an explicit rule. And by the way, in Algebra 1, we sort of typically define this recursive rule in an inappropriate way. So we're going to clean that up right now, what that means. So for part A, it says write the common difference. So let's go ahead and write out the sequence values. It's 15, 13, 11, 9. And that's an infinite series, goes forever. It goes down to the negatives and goes off to negative infinity, right? All right, so what is the common difference? D. Because the sequence is decreasing, the common difference is negative, so it's negative 2. What is the eighth term? 9, 7, 6, 5, 9, 7, 5, 3, 1. The eighth term is 1. The way you want to write that, a sub 8 equals 1. That's how you write that the eighth term is equal to 1. Recursive rule for the nth term. So what is a sub n? And what do we mean by recursive? It means defined in terms of the preceding term. So the preceding term, and this is an important concept we're going to use a lot. If a sub n is a certain term, then the term right before it is a sub n minus 1. Right? If this is a sub n, this is a sub n minus 1. As you can figure that out. Why it's notated that way, okay? And so what this is saying is, how do I get one term from the preceding term? Well, I subtract 2 from it. So this is the correct way to write a recursive rule. A sub n equals a sub n minus 1 minus 2. Sometimes we put a sub n plus 1 here and a sub n here, but the question specifically says a recursive rule for the nth term. So here's the nth term. We have a recursive rule for it. Okay, and then D is an explicit rule. So for the explicit rule, we just look at because I can't remember, I'm going to cheat and look at this. Oh yeah, here's our a sub n equals a1 plus n minus 1d. So a sub n equals a sub 1, which is 15, plus n minus 1 times negative 2. You could probably just leave it like that. I mean, if you want, it's nice to put 15 plus negative 2n. I should just put just minus 2n. And this guy's going to be plus 2. So you could say 17 minus 2n. So that's nice. A sub n equals 17 minus 2n. All right. That's how you do things like number 12. And then for number 16, well, maybe we'll just do number 18 instead. So number 18, this one, it specifically says the sequences are geometric. So remember I said we can't assume. They tell you these sequences are arithmetic. These sequences are geometric. If you didn't know that, you would have no way to assume what the nth term is. It could be anything. All right, so number 18 goes 5, negative 5, 5, negative 5. Is that really a geometric sequence? Sure it is. This is a geometric sequence. I'll go ahead and write here, even though they didn't ask. A sub 1 is 5, R is negative 1. So you can see how that works, hopefully. Okay, so part A says what is the common ratio? So we're going to say R equals negative 1. Part B says, what is the ninth term? I find it easier, especially for ninth term. I don't want to sit here and, count it out, whatever. We can just, if I have the explicit rule for the ninth term, which is part D, then it'll be easy for me to get the ninth term. Okay, so explicit rule for the nth term, I will go back to here, a sub n equals a sub 1 times r to the n minus 1. Don't forget the minus 1 up there. So a sub n equals our a sub 1, which is 5, times r, which is negative 1, to the n minus 1. So it's kind of interesting to think about how this n minus 1 works for this sequence, because it means that when I do n equals 1, I have to get the positive 5. So n equals 1, if I didn't have the minus 1 here, I would have 5 times negative 1, I would have negative 5. So the minus 1 makes it so I go 1 minus 1 is 0, negative 1 to the 0 power is positive 1, times 5 is positive 5. All right, and then when I go to n equals 2, the second term, 2 minus 1 is 1, negative 1 to the 1 is negative 1, times 5 is negative 5, second term is negative. So this n minus 1 sort of controls which ones are positive, which ones are negative. If I wanted the first one to be negative, I could just put, I could take off the minus 1. Or, alternatively, you could just say the a sub 1 is negative 5, have the same effect. All right, so see, once I have this, then I can say, it's easy for me to say what the a sub 9 is. It's going to be 5 times negative 1 to the 9 minus 1, and then I just go, oh, that's even, so, maybe that's thinking about it too hard. It's pretty easy to figure out that the ninth one's going to be positive. because the odd ones are positive. But, you know, for some of the other ones, you might want to get that explicit formula first. And then for the recursive rule, for a sub n, it is a sub n equals a sub n minus 1 times negative 1. Yeah. All right, that's your recursive rule. Okay, so I got a couple of more. I want to look at some of the graphing ones and some of the limit ones. We'll do that in the next video.